challenged persons and especially to persons with disabled from eyes. So in this session will be moderated by our group coordinator Dr. Devashish Datta ji, and our speaker will be today Dr. M. Balakrishnan, a professor from IIT Delhi and also chief coordinator of this particular program on textile graphics. I will now hand over the floor to Dr. Devashish Datta, please. Kindly conduct a session, please.
Thank you. As you are aware, the tactile graphic means something that you can feel about, and it is used specially as a ICT aid for Divyang person or disabled persons. So, Professor Balakrishnan has been working in this area for quite some time, and his passions in other medical devices like magic canes, and not only related to disabled sector, he has worked in the other sectors too. But our engagement from the department was development of tactile graphics in which useful forms of books could be developed for visually challenged persons. Now I will request Professor Balakrishnan to take over and explain the concept to the audience and how we have gone about and what is the success.
We have been working in the space of assistive technology for visually impaired now for more than 10 years. In the earliest work, which Dr. Datta also mentioned, we developed a device called Smart Cane. Today actually the device is being used by 15,000 users in India all over the country. It's also part of the ADIP program, and recently Prime Minister also distributed 1100 canes on his birthday. So it's become very popular. But when we are doing this Smart Cane, one of the things we wanted to do was a self-learning manual. That means that the visually impaired person, when he gets a device, how does he actually understand how does the device works? It requires some amount of, reading about the device, about the principle. We would also like to explain what the basic ultrasonic ranging principle that it operates on. When we were doing this, we ran across a big bottleneck. The bottleneck was that the braille is actually quite popular in India. Government has actually spent a lot of effort and time and money in setting up what are called these braille presses. We have braille presses all over the country, which actually produce fairly subsidized braille material for the visually impaired. But problem is the braille is only suitable for text. Any language text, any major Indian language text can be translated into braille. It's a very universal script. More than 150 languages in the world actually use the braille script. But the challenge was we had some figures as part of the manual, which basically shows how ultrasonic ranging worked, where the switches of the device were, and so on. And then we realized that actually we do not have any standard technique to produce tactile diagrams in this country. And this was in sharp contrast to, because as part of the project, because the project was also sponsored by a charity in UK, we have been visiting UK and we also been looking at material, what visually impaired people use in developed countries. We found that the whole space of how do we make tactile diagrams was extremely advanced. There are many, many techniques, there are many, tactile designers. Actually, a country like UK, which is so much smaller than us, actually has more than 100 tactile designers employed by this particular organization to just produce tactile diagrams for UK. Then what it came to us was something which is so basic as pictures. And then we came back and discussed with what type of material is in braille and remove the pictures. And as a lot of volume work is required, people don't even remove the reference. So there will be a reference like figure 3.2, but there will be no picture with it. So now imagine a plight of a visually impaired student who has to read such textbooks and compete with sighted children in examinations and write this exam. So clearly we were in a very, very weak situation. And when we talk to the visually impaired, organizations, NGOs, blind schools which work for them, they do have some tactile diagrams, but these are all locally produced, not very accurate, and it all dependent upon how much effort the teachers would like to take to produce the material. So school after school will produce the same material because no production methodology exists. That was the time when we approached AT with this project proposal some 3.5 years back, saying that we could actually develop this whole technology for producing tactile diagrams right from the basic, because this is something absolutely missing. And today, I'm very glad to say that we have reached a long way from where we started. We have the full technology. I will talk about it a little later. And we also have been working with organizations like NCRT closely in actually producing books and testing and validating it.
One of the main challenge in this sector is standardization. So, in your work, how did you manage to develop standards, or is there a need for develop certain standardization for these kind of figures,
Okay, so let me, actually maybe I can first show you some figures, and from there it may be easier to discuss what we will talk
Right.
about standardization. So, those viewers who have not seen the tactile diagrams before, I'm showing you one diagram which is actually a map of India, and what you can see is it looks like what is embossed on a paper. But the interesting thing is the process of production, and we will talk about it
Right.
because affordability is important, and next time we'll take it up. But let me talk about standardization as the question Dr. asked about standardization. See, what we have is, in this world, there are what's called guidelines. These guidelines actually act as standards. Presently, we don't have any Indian guidelines. We are working with two different set of guidelines. One comes from UK, which is RNIB guidelines, and one comes from North America called BANA guidelines, Blind Association of North America. And these guidelines are extremely important because what it says is, how does this diagram, so it is not a direct conversion of a sighted diagram to a visually impaired diagram. If you do a direct conversion, especially for complex diagrams, comprehension of them is going to be very, very difficult. There are guidelines in terms of what are the resolution, because it's a touch sensation, the resolution is much lower than what eyes gives you. So for example, in this diagram, on the same page, I cannot show the northeast states and rest of the states, because the northeastern states are much smaller. If I draw them in the same sort of a picture, it will actually, what will happen is, the user will not be able to differentiate between various states. So these are the type of guidelines. So what it means is, just like you see in a newspaper, you see an inset and then blown up. So such diagrams need to be broken into multiple diagrams. So for example, the northeast would have to be drawn separately on a separate page. And here a reference has to be given that this particular part is actually blown up in a separate picture. This is how the diagrams are built. This is just one example. Whenever we have colors, these colors are actually replaced by what are called tactile shading. That means I can put dots and dot density, or I can put squares to mark various regions. Like various regions in a map or even in other pictures, we differentiate using colors. As colors cannot be perceived by a visually impaired, it's important that I have this tactile shading. Again, there are guidelines on how many tactile shadings you can use in a diagram, how close they can be, what type of tactile. So these are all part of guidelines. There are, a very large number of guidelines. And these guidelines have been developed over, almost I would say 50 years of research with comprehension that the visually impaired. But there's one great opportunity here. These guidelines all came when the production methodology was completely manual. A typical production process of tactile diagrams is you take a normal diagram, scan it, and use software like CorelDRAW to simplify the diagram, to replace these colors by tactile shading, edit it, put braille labeling onto it, and so on. So that's the normal method. It's a manual. Manual in the sense you're still using computer tools, but it has to be done one picture by the picture. But all these guidelines came when all this process was actually manual. But now as we are going for more computer generated pictures, there is a huge scope to actually improve on these guidelines. And not only improve on these guidelines, the work that we are doing as part of the Center of Excellence is actually develop a software which actually knows these guidelines in the background. So it can take a picture, use simple image processing techniques, and create diagrams which are actually compatible to these guidelines. Because please remember our challenge. We have thousands and thousands of textbooks today that needs to be converted. We have so many boards, so many languages, and even boards also sometimes have alternative textbooks. And all these textbooks, even if we confine ourselves to school textbooks, we need to convert so many textbooks into braille. If campaigns like Sarva Shiksha Abhiyan have to be successful, that means books have to be available to the visually impaired children. And there are any estimates of million plus children who actually need such books even today. So issue is, how do we actually make those books? And if we want to do through a manual process, not only it is going to be expensive, but it's also going to be extremely time consuming. At this point in time, we have very few tactile designers available in the country. Okay, we have to first train them and then do that. So what we are looking at is a process of automatic generation of software, which will be first global such software tool. We are hoping that in another few months we will have the first version of it available as an open source software which people can just download. And that makes the whole process of conversion, at least for simple diagrams. Some manual work will be required. The whole conversion process will not be fully automatic, except for simple diagrams. But even then, the manual work will be so much reduced that productivity of the tactile designers in producing these tactile diagrams will actually increase considerably.
You have said about the image processing and the software algorithm being extensively used. Over the journey of tactile graphics, which almost you said about 50 years it took to come with the guidelines. Now, what exactly, how do you do from suppose I have a text in a figure, a document, how do you use the actual image processing, scan or capture, and then transfer it to maybe 3D printers or whatever? Could you please explain that?
So, when we are looking, as I said, that initially we looked at how tactile diagrams being produced globally. And I will show you one example of the same diagram produced on a paper called swell paper. This is a tactile diagram and it is produced on swell paper. The embossing is not that sort of strong, but it is good enough for a visually impaired person to read. And it's a very clean process. The process essentially, you scan the picture. Of course, finally you have to convert it to what's called SVG. And in this particular swell paper technology, you can actually print it on a laser printer on a specially chemically coated paper. And once you heat this paper, it swells wherever the carbon is deposited. The process there is that the carbon where it is deposited by the laser printer, it swells and it produces a picture of this type. Process is simple. It can be, of course, you need this heating methodology, something which heats this chemical. But the challenge is the cost of producing this particular picture is roughly 150 rupees. And that makes the whole problem extremely complex in a country like ours. Imagine a textbook which has 50 to 60 such pictures. Just the cost of the textbook for these pictures will be 7,000, 8,000 rupees. How do we make them in bulk and distribute it? And now the whole book will become almost 10,000 rupees or, with the break. So we were very clear that we not only have to develop a process, but we also have to develop an affordable process. And this has been something which has been the central to our lab. It's not that the solutions do not exist for visually impaired, but the solutions that exist are actually not available because they are just so expensive. So we started from the basic, and what we do is, we do what's called, all of us understand that 3D printing is not only becoming very widely available, but also very inexpensive. So we prepare a base with a 3D printer, and for example, this is one such base, and use this base to actually produce a thermoforming. So this is the thermoform sheet that we have. And what is interesting is this process, even if you are producing something like 100 copies, this will result in something like 15 rupees per sheet. So something which is costing 150 rupees per sheet, you can bring it down to a tenth, and that's really, in terms of affordability, that's a breakthrough. So in terms of the cost of the sheet itself, of course today these Braillon sheets which are of this quality gets imported. I'm sure over a period of time we will start having such sheets also produced in India, and the cost may even come down. But the sheet itself costs only some 8 to 10 rupees per sheet, and then the whole process of printing and so on, binding that goes on to it, because you have to do the braille work also on it. So this process of actually production using the 3D printing and the technology to actually produce this gives us a very affordable way of mass production of books. See, the challenge was people still were using thermoforming. What people will do is they will take a picture, actually paste a set of wires on the, let's say, boundary of a map, and use this as a mold to do thermoforming. This is how most of the blind schools were using. So they had a library of such thermoform diagrams which they were using. But clearly neither a scalable process, nor a user can do it, nor a production process. Any textbook, let's say, if everybody were to write their own or draw their own pictures, it's like every school were asked to draw their own pictures and then teach.
Right.
This was the stage that they were in. And now what we have is now a process which is completely scalable. We can produce hundreds and hundreds of books using such a process, and in a very affordable manner. So a lot of effort in the project that was sponsored by DT went into perfecting this technology of how do we do 3D printing, how do we actually produce these sheets so that we can get the right resolution, and that's one part of the work. Second part of the work was the having actually trained tactile designers who will actually produce books. The third part of the work is the software tool chain, which will actually take the scanned pictures and automatically or semi-automatically produced. We have made, very good progress in steps 2 and 3. The last one, that is the software part, as I am mentioning before, we are hoping to release our first version in the next couple of months. And then we will like to keep on perfecting it, and that will obviously take some time because certain versions which will be able to handle. Going back to what you asked about image processing, the type of techniques that we use from image processing is segmentation is important, which identifies regions. Because we convert into SVG, we also do identification of lines, circles, and such geometries so that it becomes a scalable vector graphics, because in the end, what I need is not a I should know, I may have drawn a circle, but I should know it's a circle with a certain radius and so on, and a center, so I can actually move it around and I can operate on it. And then because we also do this, we have to do the recognition of the text, because the text part of it gets recognized and then converted into braille. And that braille, because the size of the braille and size of the text is not the same, we don't use so many different fonts in terms of various sizes in braille. So the sizes are different. So I need to have a mechanism to be able to reposition it wherever I not want, still closer to the region, so that so typically, for example, we label the region. If we draw the diagram, we will say that the name of a state, Karnataka or Madhya Pradesh, we will write inside the region. But if I'm shading it, please remember, if I write something inside the region, that shading gets disturbed. Right. Because I have to write now braille inside this. So typically in guidelines says that whenever you want to label the region, please label them outside. If at all you put a minimal, let's say you may put a code, you may say that this is code 1, code 2, but label it as what 1, 2 and 3. So these are all part of the guidelines, because if I make a big square and label it, visually I can see that's the whole region. But if you are doing it tactually, then you will actually miss. You may think that, okay, this is another region that has come, which is a rectangular region, which belongs to another state. So the tactual part is very, very different than visual reading. And that's very important that guidelines you have to follow.
Now that we have more or less freezed upon the technology, how do you see a country like ours, deployment, delivery mechanism? As an institute, you have done and excelled, But if you have to see that entrepreneurs come in, takes it forward, and then pushes it to the disabled sector or the disability sector, then it will be more, it can be kind of an economic model behind it. So how do you think that this challenge can be overcome?
Yeah, I think this is a very, very interesting question and very valid question. Even when we are doing the proposal to DIT, we were very clear that we can develop the technology. The role of IIT will be to develop both the software flow and the technology and so on. But finally, the scaling and delivery has to happen through a commercial, let's say, ventures. The reason is very clear. It's like publishing. These people have to approach various boards, various agencies which are in the process of making textbooks, offer their services, take the orders from them, and produce this with a certain quality and certain timeline, and produce it in volumes. First of all, even when we proposed the project to IIT, IIT was very clear that you can do the R&D part of it, but production part of it, it's not IIT's role to do it. So we were also very clear that IIT cannot produce. You need thousands and thousands of books and various languages. You need, let's say, engagement or collaboration with various agencies which can do various language braille. And there are other issues involved in it. I will talk about it. But important thing is incubation or incubating one or more companies which will actually take up this job is extremely important. So we are now at a phase that we have the technology. We also are getting orders. Interestingly, we have done a number of work. Something which we are committed as part of the project was 9th grade science and maths. But we also have done other work for NCRT. We have done for other agencies. And like we have done an economics book. I showed you the map book. And this map book is already very popular. So the NCRT wants thousands and thousands of copies of this map book to be produced. So our challenge now is to find the right set of individuals who would actually, get inspiration from all the government initiatives that people are talking about, in this space of Startup India and things like that, and take it forward into the market in terms of incubating a venture. So that is very important. That's the stage we are in. In this context, I only want to mention one thing, which is somewhat of an hindrance for us, and which people who are in the policy should look into. One of the challenges is NCRT has no problem in dealing with IIT. NCRT says that you produce the books, we can give you the order, we can make the payment, you tell us what the funds are. But once I incubate a company, because the company will be typically for-profit company, because that's what will make it scale, it becomes a challenge for a government agency like NCRT to place orders on them. Okay, because there's single quotation, there are no issues that come in because it's a proprietary technology as of today. So we need to work and we need to really modify our ways of engagement, because then only the Startup India things can actually come in sectors like this. Because in sectors like this, if I'm doing a technology transfer, it doesn't make sense for me to give technology to 10 people. There is initially there's not enough market, or there's a huge need, but people still have to be convinced that yes, conceptually it is something that works. It is something that you need to incorporate. And these agencies also have to get more funding, because they have only been getting funding for Braille books. They have not been getting funding for tactile diagrams. And Braille pages, is 4 rupees or 5 rupees per page for a Braille. Now it's 15 rupees for a tactile diagram. So there are costs involved. But then it's very important that people have to get this tactile diagram. So, but then there is a lag between the time when this funding will become available. So it's important that we start looking at campaigns like Startup India in a holistic manner, so that the challenges that come for young incubators working in sectors like this are well supported. Okay, so that's a very important, and some of them are policy issues. We are talking to NCRT, we still don't have a very good solution of how do this incubation company will actually get these orders that we are talking about, even we do the, because this is not a sector of where private players are there. It's not a private publishing book company makes these books and sells, because these books are given typically almost free of cost to all the visually impaired children in the country. That's part of the social commitment. And so these books will continue to be given like this, which means that either some government agency or maybe sometimes charitable organizations will buy it and distribute these books.
As a country, we have been doing very good in the print and the advertisement media. Now, with the advent of the technology you have, globally, what kind of difference can we make if we catch up on this area and the opportunity that can be there?
So I think we have a huge opportunity here. Of course, huge when I say you cannot compare to the normal publishing, because it's still a very sort of niche sector. But I can very well see that some successful entrepreneur taking it to, and in the 5 years scaling to 200, 250, 300 BPO type of operation, where they have tactile designers and doing work for global organizations. Okay. Even in the short period we have been there, some conferences we attended outside India, people have already started talking, can we get orders? Because, can we get these tactile diagrams done in India? Two reasons. Cost of production, there is a lot of manual effort in terms of tactile diagram design. The cost of production of those diagrams is much lower. And second, I told you, this process of producing through thermoforming is also cost is much lower. So an entrepreneur who invests in actually creating a platform where you have a large number of tactile designers employed, serving the local needs. Of course, our local needs are huge. And please remember, such needs exist not only in India, but almost the whole of the developing countries. So in the developed country, the challenge is, of course, we would have to compete in quality because they have technology. And society can actually subsidize, though this may be $2 per sheet, but $2 per sheet is something, or $3 per, is affordable for a country like in Europe or US perhaps to subsidize for the small number of visually impaired they have. Countries like us, we have a large number of visually impaired and we have no such technology and no such existing books. Interestingly, as we go ahead, these are also other implications. The same technology can be used in sectors not only for visually impaired, even for other children. When you are making diagrams which have a third dimension to it, so when it is tactile, actually from touch and feel, there are a lot of things that can be done with it. So couple of offshoots I will talk about, which is actually very interesting way of how the research is going. So this work, from this we have also got into what are called audio tactile diagrams, where you can use something like a mobile to give an audio commentary on the diagram. So one, actually a girl intern who was interning with us has got so fascinated by it that she is actually doing a startup today in the space of audio tactile diagrams. And these audio tactile diagrams have other interesting things, like you can actually easily do it for children books, children who cannot read as yet, or read, are sometimes some reading disabilities, or even reading is not come to a stage of reading when they can actually learn about a diagram. Very, very language, you can translate it to multiple languages, the same book, because the audio can be very much more easily translated with all the translators which are becoming very popular. So that's one space. Second thing I want to talk about, which is creating a very interesting research problem for us, which we want to look at it, is visual reading and tactual reading is completely different. In visual reading, once I see a picture, I first understand the global picture. I will know that this is a picture of let us say a trade fair. there are lots of people, there are pavilions. I will first understand that. And then I will go into the details. So it is a top-down approach to actually understanding a picture. In case of tactile reading, it's actually completely the reverse. The person who is visually impaired, she will actually start by touching parts of the picture, and mentally she has to integrate the picture to get the whole. So the person does not have the whole picture. So even if, let us say, you have give a picture of 3 people playing in a ground, let's say playing football, and in that view there are only 3 players and there is a football, we will immediately know that there is a game of football going on, and then we will know there are 3 people, and then we may look at it, who is bigger, smaller, whatever description we want. But imagine a visually impaired person actually reading the same picture. Depending on where he starts or where he or she starts, may see just the ball. Will not know that it's actually a game going on and this ball is only part of it. Then he may see a person. And so the integration will happen bottom up. And this poses a huge challenge. And it has created a very interesting problem. When I write textual description, I write it for a sighted person. If I'm having a game of football, I will not start by describing this is a playground and people are playing football and there are, in the view you can see 3 people, because this will all look very boring for a sighted person to go through this description. Whereas all this is actually required for a visually impaired to read the diagram. It makes it much more simpler if I give the global picture on top. One of the very interesting machine learning problems we are looking at is, because today picture understanding has become a very important problem, and in a very different domain people are actually writing commentaries. There are sites you can just deposit a photograph and it will write a description of the picture. We want to use that technology to actually augment the text automatically. Because if I can augment the text automatically, this gives me a huge power to augment thousands of textbooks that we have. Because we still are doing, I would say, only one part of the job of converting a diagram into tactile using the guideline. But this by itself is useful, but not completely effective. I should also be able to automatically augment the text with this global picture. I should know from the text where actually I am describing this figure, and then write a few lines about that. And that will make the whole project very interesting and use very modern techniques that are today people are understanding.
No, what I could understand basically, the level of abstraction in which you will be doing, they will be at a primitive level, moderate level and at the top level. So here it starts at the primitive level, and to go at the topmost level he has to go through a considerable. So I think you are very right. There will be a lot of research areas in which the abstractions could be extracted from the primitive level and then taken to the next level, or meet at the middle level strategy needs to be adopted in this.
Yeah, I think you have made a fair point. Actually, the work of assistive technology in IIT Delhi differs from typical research labs in this particular mode that we start from the user. We try to solve the immediate problem of the user and then identify the research problems and look at it. Typically, most research labs would go the other way. First, they know the technology and then they try to find a user for it.
Right.
But we having been focused on education mobility as the theme of the lab, we are looking at what challenges they face in the space of education mobility. First, create a solution, because we want testing and validity to be done. Create a solution at a very low level where they can actually use the device, use the technology, and give us the feedback. And then look at more, let's say substantial research problems, which we can tackle as part of the research institution.
Thank you. At this point, if there is any question from the audience or any other person, you're most welcome.
Just I wanted to know one question. When we are shifting the domain, in the sense when we're going from one subject to another subject, how this image processing will remain the same, or we need a very special teacher or expert in that area, sir?
Yeah, I think it's an interesting question. So, image processing techniques. So, if you have a superset of all the image processing techniques, one could actually create a single tool. But at this point in time, for example, we do both maths and science. This is what we are handling. So we do have to specify when somebody scans a picture, whether he had to scanning a maths picture or whether it's a science picture. The underlying tools that we use are little different because what works very simply for maths do not work for science. The science pictures are much more complex. Maths pictures have a lot of line diagrams because we are talking of things like geometry and things like that, a lot of line diagrams. So at this point in time, to get better output, we actually tell the tool what we are using. Okay. But yes, over a period of time, the tool can become much more stronger and actually can learn these things, can actually adopt itself. But we are not at a stage, at least the first couple of versions of the tool. The user would have to say that. So the way we are looking at it is still a production type of process. So it is actually a organization which is using the tool. So it is, let's say, designed to convert a maths book into, so it will get some 50, 60 diagrams and the person will keep on taking one diagram at a time and converting it into that.
Okay.
But yes, the question is very relevant. The techniques are little different.
Same.
So we need to have, because the sizes of the, the geometries involved, the sizes of the segments involved are different. The colors, schemes are different, and those things needs to be taken.
Thank you, sir. Thank you.
Thank you.
So, sir, since there are no other questions, we are come to end of this session. And at this juncture, I would like to convey our sincere thanks to Professor M. Bala, who is working for a very novel cause, enabling the Divyangs in achieving more and more knowledge. I will also like to thank Dr. Datta for sparing his valuable time and conducting this session. Now, I will request Dr. Datta to hand over a memento to Professor Balakrishnan, sir, as an appreciation from this forum. Thank you very much, sir.
Thank you.